pathetic. You should know. I'm sure you can tell. They're still pathetic,
Well,
but yes.
you're pathetic too. How do you feel now, huh?
Fine, I can be pathetic.
Sorry, I'm pathetic too.
Okay, we are about to do, we're doing special angles all day today here, but we're about to go do special angles. The third page of the worksheet where you have to go backwards with the special angles. And I already have some brilliant people in this room who did it and figured out how to go backwards already. So, but when I say we're going to go backwards, what I mean is they're going to give you a trig function, and in this case, say cosine equals a negative 1/2. They want you to find the angles where cosine would equal negative 1/2. Now, you're going to see in the instructions that it restricts you to this interval. And the question is why? Why are they telling you your answers have to be between 0 and 360 degrees?
Because it has to.
If they don't say that, you would have to name every coterminal angle that stops there, which means you'd be naming angles for the rest of your lives. Because there would be an infinite number of angles, so that you can go around the circle and stop there, go around the circle and stop, go around the circle and stop. You'd be naming answers forever. So they're basically saying, name all the angles when you go around one time, is what you're after. Which in most cases means you're going to have two answers. The only time you're going to have one is occasionally when you're sitting on a quadrant line. So, you're always going to want to draw a picture, and basically you have to do 3 steps. You have to figure out what quadrant would we be in, quadrants I should say, plural. So find the quadrants. In this case, how do I know what quadrants cosine is negative in? All-star trig class, you would look at it and go, oh, look, cosine is negative or not written in the second and third quadrants. So we're actually going to have an angle in both quadrants. Then you need to figure out what reference angle am I talking about. At what angle is cosine equal to 1/2?
My nipples are sensitive. Sorry.
We do not want that on our recording. Evan, where's cosine equal to 1/2?
Cosine equal to 1/2 is somewhere over.
Come look at the table. Cosine's 1/2 at 60 degrees. The whole world is whispering 60 degrees and you're not even listening to them. So, now, realize you got two angles here. So you got a triangle up here with a 60-degree angle in it. You got a triangle down here with a 60-degree angle in it. You're going to get two answers. So then finally the last step is name the angles. So if you're actually going to name the angles, you're saying from 0 over to that line, how many degrees is it? Well, if this is the 180, aren't you 60 degrees short of that? So you're at 120 degrees. Then name the other angle, start at 0 going around to the second one. How many degrees is that? Well, you're at the 180 line, but you're going 60 more past it, so you're going to get 240. So your answers in this case are 120 degrees and 240 degrees for your two angles. Is that amazingly difficult?
Well, that's a negative sign.
Okay, these are angles. Angles, for an angle to be negative would mean an angle is going backwards around the circle. We are not doing that. So the negatives you're worried about are on the number. That's how we figure out the quadrant in the first place, is because we had a negative 1/2. Okay, let me throw another one at you. Suppose I asked you for where is tangent going to be? No. Okay. Tangent is going to be equal to a negative square root of 3 over 3. What quadrants are you in if tangent is negative? I heard a second and fourth. Because by all-star trig class, tangent is negative in second, fourth. So you're going to draw a triangle in the second, you're going to draw a triangle in the fourth. Okay, now you need the reference angle. Looking at your special angle chart, where is tangent equals square root of 3 over 3?
30, I'm guessing.
30 degrees. So we would put 30-degree angles in the triangles. And now name the angle. What's the angle from 0 to this line?
I'm guessing about 150 or something.
Yeah, because it would be 180 minus 30 degrees, so that would give us 150. And if I go to the next one from 0 all the way around,
I'm guessing 330 or something.
I'm 30 degrees short of 360, so yes, my answer would be 330. And those would be my two answers. Okay, one last one on that. What do you do if it lands on a quadrant line? Suppose I asked you where,
Cosecant is undefined.
see, Evan, would that be on the worksheet?
No. Yeah.
Yeah. Okay, we'll do where is secant undefined. It was a valiant effort. So I want to know where secant is undefined. Okay, first of all, if you see zeros, ones, or undefined, you should think I'm on a quadrant line. Unless it's tangent, because tangent is 1 at 45. Well, most anytime you otherwise, if you see 0, 1, or undefined, you think, I'm sitting on a quadrant line. If secant's undefined, secant's the reciprocal of which trig function? Cosine. So if secant's undefined, that means cosine equals what? Undefined is 1 over 0. What's the reciprocal of 1 over 0? 0 over 1. So in other words, we want to know where cosine equals 0. So you would just go to your chart. This is just kind of a common sense look at it deal. You go to your chart and go, where's cosine equals 0 at? 90 degrees. So therefore, since it equals 0 at 90 degrees is one of my answers. Now, the thing you have to ask yourself is, would it also be 0 down on the other quadrant line? Down at the bottom, since that's the same line, would it also equal 0 down there? The only thing that changes from the top part of the axis to the bottom is the positive or negative. Since we're equal to 0, do the positives or negatives matter? They don't matter. So yeah, it actually would be at 90 and 270. If it equals 0, you're going to have two answers. There's going to be both quadrant lines. So on those times when it sits on a quadrant line, there's really no work. It's just a kind of a common sense think about it deal.
Whoa, I'm not getting it.
We're waiting for Evan. I didn't pick up my notes, which might be a good thing. All right, our major topic of the day is radians.
Alright, we're good.
Radians are awesome. Okay. Why on earth do we need radians? Why aren't degrees good enough? Why do we need to measure angles in another form?
Because I'm guessing there's pi and stuff in it.
Well, the problem is, can you take 20 degrees times 6 feet?
Well, there's numbers in it.
What would you get? 120 degree feet?
Feet,
Doesn't make
degrees.
sense. You can't combine degrees with measures of length. And so mathematicians of the past said, we need to find a way to relate an angle to a distance so that we can actually combine angles and distances. And so somebody who in their utmost brilliance said, okay, let's make a connection, a way to measure an angle that's defined by the distance of something. So what they did is they said, okay, we know a circle has a radius. I am going to measure off along the edge of the circle. I'm going to measure off the length of the radius. So if this is how long the radius is here, I'm going to measure along the edge of the circle and try to measure the same length. And I don't know that I'm exactly perfect here, but I'm close. That's also a length of r. So if you then form an angle at that point, you come through here and form an angle, that angle you just formed where the arc is the length of the radius, that is a 1 radian angle. So an angle of 1 radian is an angle whose arc is the same length as the radius.
That's dumb.
Now, the cool part of this, it doesn't matter how big your circle is. If I draw a little bitty circle, that means my radius got shorter, right? If I mark off that shorter radius, I will still get the same size angle. That angle will still be 1 radian. The angle will still be the same regardless of how big or small your circle is. So the angle can vary proportionally with the size of the circle, which is pretty sweet. Now, problem is, a 1 radian angle, it's not a nice number. It's about 57.3 degrees. Yeah, you really don't care. 57.3 is not a very helpful angle. So they said, we got to have another way to connect radians and degrees and be able to compare them. Let's find a nice connection to them. So somebody said, all right, we know here that our one radian angle marks off an arc, so that is r in size. This is not good. It keeps freezing. Okay, so we're setting up a proportion here. What's another length we know along the edge of a circle? You know circumference, don't we? Okay. How many degrees is the angle if you're talking about circumference of a circle? 360 degrees, yeah. So we know that 360 degrees is the same thing as the circumference, which is 2 pi r. So we have that proportional relationship. We can do this ratio.
I swear we did this last year.
We did do this last year.
All right. Hey, you have 1135.
Thank you for that. So I am cross multiplying here. That would give me 2 pi r times 1. So and actually would be 2 pi r radians equals 360 times r. They both have an r in them, don't they? So if I divided the r out of both of them, it would cancel. And so I would be left with 2 pi radians is equal to 360 degrees. Or if I divide the 2 out of there, wouldn't I be left with pi radians is 180 degrees? That's the relationship you need to remember forever, connecting radians to degrees. Pi radians is 180 degrees. If you look at the clock, you will notice that the pi on the clock is located at 180. Pi radians, 180. So why on the clock, when you look straight up, why is the top of the clock pi over 2?
Because there's 2 underneath the pi.
Pi over 2 means half of pi. What's half of 180?
90.
90. And isn't that the 90-degree angle?
No.
Yeah. So the clock is just simply marking off the radians, same thing. Okay, if you need to convert from radians to degrees or degrees to radians, there is an easy way to do it. We're going to convert to radians first. If I was to give you 120 degrees and say, hey, convert that to radians. Okay, do you remember when we convert units, we make our units cancel?
Oh, yeah.
So I want to make degrees cancel. This is pi radians is 180 is the relationship I'm putting in there. So am I going to put the degrees on the top or the bottom?
The bottom.
The bottom, because I want the degrees to cancel. And I'm going to put the pi radians on top. The degrees will cancel, and my answer then will be in radians. When we write answers in radians, we write them as fractions. We don't turn them to decimals. You can turn them to decimals, but they're icky, awful decimals. So all you will do is you will just reduce this. You've got 120 over 180 times pi. How much can I reduce that?
Pi over 3.
Yep, that reduces by 60, so we would get 2 pi over 3. So 120 degrees is the same thing as 2 pi over 3 radians. So not that big a deal. Okay, what if I wanted you to convert the other way? I wanted you to convert 2 degrees. Say I gave you 25 pi over 9, and I said, how do I go 2 degrees?
Hurry up.
Yep, you got 30 seconds. Too fast.
I don't know.
Hit. If you did pi over 180 here,
Flip it over.
flip it over. You do 180 over pi here. The pi's will cancel. You just have to crunch the numbers. 25 ninths times 180. You'll actually, that's cheating here, 500 degrees.
10, 9.
All right.
8.
We are pausing for a new one.